Hello everyone. In this video I'm going to be looking at an example of solving radical equations. In this case I have two radical equations on each side of the equation, and because they're both square roots, they both have a index of 2, I'm able to simply solve this. If, for example, one of these had been a square root and the other had been a cube root, then I wouldn't be able to go any further. So the first thing I'll do is, since both radicals are isolated on each side, in other words, they are the only thing on that side of the equation, I will raise both to the power of 2. And again, the power of 2 because they both have an index of 2, or are square roots, same thing. Doing so will eliminate my radicals, and I'm left with 3x plus 4 equals 5x plus 7, minus the radicals. I'll continue to solve for x now. So I'll subtract my 5x in this case from both sides. That leaves me with a negative 2x, still plus 4, equals 7. I'll continue to isolate my x, I'll subtract my 4 from each side, leaving me with a negative 2x equals positive 3. Continuing to solve for x, I'll divide by negative 2. So I have x equals a negative 3 halves. Now, like any radical equation, I want to solve, or excuse me, I want to, check my answer. Because of the nature of this problem, it's possible to get extra answers or extraneous solutions. So I'll substitute my negative 3 halves back into the original equation, leaving me with 3 times negative 3 halves plus 4, and actually what I'm going to do is I should take this to the other side, give myself a lot more room. So 3 times negative 3 halves plus 4 equals square root of 5x times plus 7, so 5 times a negative 3 halves plus 7. Now I just want to make sure that both these sides are equal to one another. So over here on my left I'll have negative 9 halves plus 4. Here I'll have on my right side a negative 15 halves plus 7. Getting a common denominator, here I'll have negative 9 halves plus 8 halves. Here I'll have negative 15 halves plus 14 halves, which will leave me with a square root of negative 1 half and negative 1 half. Now you might be saying, well, that's a negative inside a even number. And if we're not considering imaginary numbers or complex numbers, we shouldn't be able to go any further. What we want to show is just that both sides are equal to one another, and they are. That is enough to show that our answer of negative 3 halves will work. So when you have two radicals on each side of an equation, if the indices I should say, match up, we raise both sides to that power and solve for x.